Now, if you look in Orris's, in this mini lecture, what I'm going to do is compare ANOVA to the two-group difference of means test with independent groups. Remember, I've kind of reminded you on several occasions that as long as we only have two groups, we can do the two-group difference of means test. When we go to three groups, we have to do ANOVA because the two-group difference of means test can only handle two groups. But you actually can do ANOVA when you've got two groups. It's just that it's not necessary. And Orris addresses this on page 210, section 11.3. So what I'm going to show you here with a numeric example addresses Orris's points that he makes on page 210, section 11.3. And what you're going to find is that whether we do ANOVA or the two-group difference of means test, as long as we run the alternative hypothesis as a two-tailed alternative on the two-group difference of means test, we get exactly the same results. Okay? So I'm going to work with this data here. And again, you might recognize this data. We worked with it earlier when I was trying to teach you some things about the two-group difference of means. So we start out with this as our screen. And the first thing we do is we click on add-ins. And then we go over to Megastat. And the first thing I'm going to do is hypothesis tests. And I'm going to compare two independent groups. Because if you're male, you can't be female. If you're female, you can't be male. So I'm going to do two independent groups. And for my group number 1, I'm going to select females. And this is the set where we have 30 females. And for group number 2, I'm going to do males. And that's our group number 2. Notice I only highlight the column header and the 30 observations. I do not highlight my descriptive statistics. That would mess up my results. Hypothesize difference. I'm going to hypothesize 0 difference. We'll stick with the t-test with a pooled variance. Our alternative hypothesis, we'll leave it as a two-tail, so that's not equal. And our confidence interval is 95%. Now, one advantage we'll have here over ANOVA is we can get our confidence interval. In ANOVA, we cannot get our confidence interval. So we're ready now to run our difference of means test. And you see here, the thing that we really have our eye on is our p-value is 0.0363. And the next thing I'll do is run the ANOVA test. Now what Orris tells you in the book is whether you run a two-group difference of means test or ANOVA, assuming you've only got two groups, you get exactly the same p-value. So when I run ANOVA next, we'll get a p-value of 0.0363. If we don't get a p-value of 0.0363, then we will not post this to YouTube. What you'll also see is the f value, which I'm not having you work with f value in this class, but Orris makes the point that the f value that you get will be the square of the t, which is 2.144. So now we're going to do an ANOVA on that same data to demonstrate that what Dean Orris says, as usual, is correct. So now we're still going to work with this same data here, okay? But now instead of a difference of means test, we're going to do ANOVA. So we go to add-ins and we click on add-ins. And then we go to Megastat and we click on Megastat. And now we're going to drag down to analysis of variance, and we're going to do a one-factor ANOVA. And I need to get to the right screen. So I'll clear all of my data out here. And I'm going to highlight my column headers as well as my 30 observations of each group. I do not highlight the descriptive statistics at the bottom. I'm not going to ask for the display partitioning. I'm now ready to click OK. And let's see if we can get, these on the same screen. So let me just show you. At the top of my screen is the two-group difference of means test I ran just a few minutes ago. Let me remind you that we got a 0.0363 p-value for our two-group difference of means test. In ANOVA, what did we get? We got a p-value of 0.0363. So as Oris indicated, whether you run a two-group difference of means test with independent groups and a two-tail alternative, or ANOVA, you get the same p-value. I'll leave it up to you, but I would assert that if you square 2.144, that will give you the value 4.59. So I don't know why you would ever want to run an ANOVA when you have two columns of data and can run a two-group difference of means test. But if you ever want to do that, you now know that you can do that. Okay. In ANOVA, we focus our eye here, but the beauty of the two-group difference of means test is that it also gives us the margin of error as well as the lower and upper bounds on the confidence interval, whereas in ANOVA, we get none of that. We get a picture, but we don't get hard data that we can use to provide additional managerial insight beyond the mere fact that we rejected the null hypothesis. Thank you.